Hey guys, welcome to part 4 of Unit 1 of a Grade 10 Math. This part will be about horizontal and vertical lines. So let's begin with question 1, and it's asking us to determine the equation of the line for each of these lines that are on this graph over here. So we can start with line A, and I'm going to just write down line A, and you can see that this line is a horizontal line, and all horizontal lines come in the form of y is equal to something, some number. And this number, we can see over here, is -3. Uh, and like that is the y-intercept technically, um, uh, which is what y is when x is 0. But you can see that y is always -3. It doesn't only have to be when x is 0. So we can just put down that y is equal to -3. And think about horizontal lines that they have the slope of 0. So if you wanted to put it in the form of y equals mx plus b, then you could put y is equal to 0x because that's the slope, and then -3 because that's technically the y-intercept, and then this 0x would just cancel, leaving you with y is equal to -3. So yeah, I'll just move this over here. I could just delete that. Okay, nice. Oh wait, not there, but over here. Okay, so now we can move on to line B, and line B is a vertical line. And the thing about vertical lines is that they come in the form of x is equal to some number, because the slope of a vertical line is undefined. So, since it's undefined, we can't just use the normal y equals mx plus b because we can't really write undefined here. But what we can do is just look at the x-intercept, because since it's in the form of x equals something, then we can just put down the x-intercept, and the x-intercept is just what x is when y is 0. And that would be 4 over here, so x is equal to 4. But similar to the last equation, x on this vertical line is always 4. It doesn't always have to be when y is 0. But that's our answer though. X equals 4. That's it. It's really, really simple to find the equations of horizontal and vertical lines. Because of that, I'll go pretty quick for C and D. So for C, this is obviously a horizontal line. You can see that it passes through y equals 5, so therefore it's just y equals 5 for C. And for D, it's a vertical line going through x equals -2, and so therefore the equation of that line is x equals -2. Nice. So those are our answers for question 1. So now we can move on to question 2. And question 2 is asking us to determine if the following pairs of lines are parallel or perpendicular. So we can just begin with A. And we have y equals 2 and y equals -2. And you can see over here that these are both horizontal lines, obviously, because they're in the form y equals some number. And therefore, we can say that the slopes for A are 0. And if you remember what the slopes are for parallel and perpendicular lines, you know that if the slopes are the same, the lines are parallel. And since the slopes are both 0, therefore the the pair for A is parallel. Parallel. Okay, now for B, you can see that this is a vertical line because it's in the form of x equals something, and this is a horizontal line because it's in the form y equals something. And we just note that the slope of a vertical line is undefined. Alright, and und for short, and for horizontal lines, that's obviously 0. But you could technically write undefined as 1 over 0, because anything over 0 is undefined. The numerator doesn't always have to be 1, it could be any other number, but that really doesn't matter here. Because if you look for 0, uh, x0 over anything is 0. So I'll just put 1 over here, because that's what it usually is. So if these two numbers can be any number and it wouldn't change anything, then we could say that these two are reciprocals of each other. And since these two can be any number, they can also be negative numbers too. So this could also be, these two slopes could also be negative reciprocals of each other. And negative reciprocals means the lines are perpendicular. So therefore, the pairs for B are perpendicular. And a shortcut that you can use from now on is that any pair of horizontal and vertical lines will be perpendicular because they're parallel to the x and y axis. So I'll just write perp for short. Okay, now for C. We have y plus 15 is equal to 0, and x minus 12 is equal to 0. So, I will just get them into a better form. So I'll just quickly write down y plus 15 is equal to 0, and x plus 12 is equal to 0. So if we were to look at this equation first, and we took away 15 from both sides, you would then get y is equal to negative 15. And this is obviously a horizontal line. And for this, oh, that's not right. This is a minus sign. And if we were to add 12 to both sides for this line, then you would get x is equal to 12. And these two are obviously horizontal and vertical lines. So it's just perpendicular. So for C, the pair of lines are perpendicular. A thing to note about seeing y plus a number or x minus some number is that you can kind of just ignore these two numbers when you're trying to determine if they're parallel or perpendicular, because these are just like these two aren't the slope, and you're only worrying about the slope here. So and you don't see the slope here, obviously, as I said before. So these two are just horizontal and vertical lines. So now for D, we have 2x equals 9. We have 2x equal to 19, and 5x plus 3 is equal to 0. And we can just try to simplify these a little bit. 2x equals 19, 5x plus 3 is equal to 0. Okay, so we can start off by looking at the equation on the left, and you can simply divide both sides by 2 to get x is equal to 19 halves, and that's just what it is, a vertical line. And for this, we can take away 3 on both sides, and you get 5x is equal to minus 3. Divide both sides by 5, and you get x is equal to negative 3/5. And these are both vertical lines, so therefore they are parallel. So you have, as their slopes are both um, undefined. So what I tried to say before is that uh, you'll know that a line isn't a normal diagonal line when you don't see both x and y in the equation. You don't really see the y here. If this 0 was y, then this would be a normal diagonal line, but it's 0. And if it's a 0 and there's no y, then it's a vertical line, because the only letter here is x. So yeah. Finally, for E, I'll just go through this pretty quickly because I think that it should be a little bit obvious by now. Um, the only letter here in this equation is x, so it's a vertical line, and this one it's only y, so it is a horizontal line. And since one is vertical and the other is horizontal, they are perpendicular. So yeah, that is the answer to question 2. Moving on to question 3. The question is asking us to determine uh, the equation of the vertical line and the equation of the horizontal line that pass through the following points. Okay, so we can just focus on A for now. And the question is really saying if this point was a vertical line, then what would the equation be? And if it was a horizontal line, then what would it be as well? So this was vertical. I'll write vertical here. Then it would be x equals something, because that's what the form is. And this point, we can just look at the x-coordinate, and the x-coordinate is 3. So we can just put x equals 3. If it was horizontal, short, a little short form of that, you would get y equals something, because that's the form of it. And look at the y value, and the y value of this set of coordinates is negative 5. So you get y is equal to negative 5. That's it. It's really, really simple, and you can do the rest of them really, really quickly. So, if it was a vertical line, then it'd be x equals negative 11, and if it was horizontal, it'd be y equals 2. Now for C, you look at the x-coordinate for the vertical line, and that'd be x equals 7, and y, the y coordinate is 9. So if it was a horizontal line, it'd be y equals 9. For D, um, if it was a vertical line, it'd be x equals 0. And if it was a horizontal line, then it'd be y equals negative 6. So yeah, this is the answer. It was really, really simple. So now we can just move on to question 4. And question 4 is asking us to determine the equation of the line that is all of this. So let's first go through A. And we have, and it says that it passes through these coordinates and it's perpendicular to y equals 3. So what we know is that it says it was that the slope is perpendicular to y equals 3. And the slope of a horizontal line, which is what that equation is, because y equals 3 is a horizontal line, is 0, obviously. And if it's perpendicular, then it'd be and if the slope is perpendicular of this slope, then the slope would be negative 1 over 0, and that is undefined. And so we know that this would come in the form of x equals something, because vertical lines have a slope that is undefined. So we can just look at the x value of this point, and that is 9. So x equals 9 is A. Now for B, it says that it's parallel to x equals 0. So the slope is going to be the same, and if the slope is the same, the form is also going to be the same. It's going to come in the form of x equals something, and the x value is negative 2. So yeah, that's it. For C, the slope is perpendicular to x equals negative 6. And so what is perpendicular to undefined is 0. Okay, so I'll just write this down really quickly. The slope is undefined. It's undefined. And undefined, as we did in a previous question, we wrote that down as 1 over 0. And if we take the negative reciprocal of 1 over 0, we get 0. And if the slope is 0, then it's a horizontal line. And horizontal lines come in the form of y equals some number. And if we look at this set of coordinates, the y value is 7. And so therefore, the equation for C is y equals 7. We can now move on to question 5. And it says for A, in this lesson, it was stated that horizontal lines will not have an x-intercept unless they are lying directly on top of the x-axis, i.e. y equals 0. So what is the x-intercept of the line represented by the equation y equals 0? So I'll just write down A over here. And the question, and if we look at the definition of the x-intercept, you know that is just what x is. Well, like just like whatever x is when y is equal to 0. But in this question, it's asking us what the x-intercept of the line is. Like, it's asking us what the x-intercept uh of the whole line that is y equals 0. And since we know the definition of the x-intercept, then the answer to this equation is just every point on the line. Because every point on that line is just when y is equal to 0. So every point on this line is the x-intercept. So yeah. If I were to draw a graph over here, a really rough sketch of one, this is the y-axis, this is the x-axis. Oh, wait, nope, that is completely wrong. That is inverted. Put different arrows over here to make it bit better. This is the x-axis, this is the y-axis, and so the line when y is 0 uh, is just this. This is the line. Wait, I can just pick a different color. This color. Like, this is the line of y equals 0. And that's on the x-axis. And if it's on the x-axis, then every point is the x-intercept. Okay, so we can now move on to B, and it says in this lesson it was stated that vertical lines will not have a y-intercept unless they are lying directly on top of the equation, i.e. x equals 0. So what is the y-intercept of the line represented by the equation x equals 0? Okay, so for this question, we can do what we did for the last question, and we just defined what the x-intercept is. Let's just define what the y-intercept is. So the y-intercept is um is the point at which the line crosses the y-axis, or just what y is when x is 0. And what we notice in the last question is that the equation that is given to us is the definition of the in this case in this case y-intercept. So, as we said before, every point of this equation is the y-intercept. Okay, that's a really bad P. Okay, every point is the y-intercept on the equation x equals 0. And that's the answer to question 5. We can now move on to question 6. And question 6 is asking us to determine the equation of the line that passes through these points. Oh wait, no. It just says the line that passes through the points A and B has the same slope as y equals 0, so we have to determine the value of t. Okay, so let's first look at this slope business, because that's the most important part here. And it says that that the slope is the same as the slope of y equals 0. And the slope of that is 0. And that is because it is a horizontal line, and all horizontal lines have a slope of 0. And with these 2 points given to us, we can use the slope formula. And that is slope is equal to y2 minus y1 over x2 minus x1. So we can plug in our slope into this formula, being 0 is equal to all that, and we can use our points for our y2 and y1, x2 and x1. So I'll put t as my y2. So we have t minus 4 over 6 minus negative 3, which is just plus 3. And and we can really just ignore the denominator here, because we set this equal to 0, but I'll still solve it just to make things a little bit easier. So we have 0 is equal to t minus 4 over 9. And so we can just multiply both sides by 9, to cancel out these 9's, and yeah, and not 9 times 0 is just 0. So we have 0 is equal to t minus 4, and if you add 4 to both sides, you then get 4 is equal to t. So that's the answer for A. Let's put a little box right there, or yeah, okay. For B, I'll just delete all that. Put this up here. Oh, no. Move that. A. Okay, so now for B, it says the line that passes through the points P and Q has the same slope as x equals 7. So you have to determine the value of S. Okay, so the slope of this equation here is undefined, and the line here has the same slope as this. So we know that we're gonna have to plug in undefined into our slope formula, which kind of doesn't work. So what we're gonna do instead is just plug in 1 over 0 instead. And we did that for a bunch of other questions we did as well. So 1 over 0 is equal to 8, that's our y2, minus 6 over s minus negative 5, which is just plus 5. Okay, and you can just ignore the numerator here, but I'll still deal with it to make things a little bit easier. And we get 1 over 0 is equal to 2 over s plus 5. And we can just multiply both sides by a half, and we get 1 over 0, because like multiplying fractions is going top and bottom. Well, 1 over 0 is equal to 1 over s plus 5. And since these ones are the same, we can also just assume that 0 is equal to s plus 5. And if we subtract both sides by 5, we then get that minus 5 is equal to s. Therefore, s is equal to minus 5. So now we can just put that up here. Okay, so now for question C, it says the line that passes through the points A and B is parallel to the line joining P and Q. So you have to determine the value of M. Okay, so we can first just find the slope of A and B using our slope formula. And I'll just use B as my second. So we have minus 2 minus negative 2, which is just, which is plus 2 over 5 minus negative 3, and that is just plus 3. So, we know that the slope is going to be 0 over 8, and 0 over anything is just 0. So the slope is 0. And now we can use this slope and plug it into the equation. or plug it to the formula. So we have 0 is equal to, we're gonna put our y2, which is 3. We have 3 minus m over 8 plus 7, because that's a minus negative 7. And we can just ignore the denominator, but I'll still solve it anyways, as I did in the previous questions. So we have 0 is equal to 3 minus m over 15. And we can just multiply both sides by 15 to cancel that out. And we get 0, because 15 times 0 is just 0, equals to 3 minus m. We can add m to both sides, and we get m is equal to 3. So that is the answer to C. Okay. Now, finally, for D, it says the line that passes through the points A and B is perpendicular to the line joining P and Q. Determine the value of n. So we can do exactly the same thing as we did before by determining the slope of A and B, or the line that has the points A and B. So we have m is equal to minus 2, and then that'd be minus negative 2, which is just plus 2, over 5 minus negative 3, which is just plus 3. And as we noted before, this is just 0, and 0 over anything is 0. So our slope is 0. But it says that this slope is perpendicular to the slope of the line joining P and Q. So we're going to have to find the negative reciprocal of 0. And that is negative 1 over 0, which is just undefined. So now we can just set this slope and plug it into our formula, and that would be our 4 for our y2. So we have 4 minus 5 over n minus negative 7, which is just plus 7. And if we can just ignore the numerator as we did before and just focus on the denominator, and that would leave us with 0 is equal to n plus 7. So if we subtract 7 on both sides, we get negative 7 is equal to n. And that is the answer. Alright, so I am just going to put this up here to make it look nice. Alright, with that, we can now move on to the next question. And you have to determine if the following statements are true or false. For false statements, you have to try to change the wording so they are true. Okay. So let's begin with A. It says the slope of a horizontal line is 0 because the rise is equal to 0. And that is true. and it's true because the slope of a horizontal line is 0, as we know before. If you look at rise over run, if we try to find the rise and run of a horizontal line, we'll get like any number that's run. So I'll just write that as n. And then rise, since it rises 0, we'll just put 0 for rise, and then this is right. The slope of a horizontal line is 0 because the rise is equal to 0. So all that is completely true. For B, it says the slope of a vertical line is equal to 0 because the run is equal to 0. So we already know that the slope of a vertical line is undefined. It's not 0, but the run of a vertical line is 0 because anything over 0 is undefined. So this second part of the statement is true, but not this part. So we have to put false. So I have to correct the statement. So I'll just make a text bubble. That's not it. How do I make it a text bubble here? This thing? Okay, I got it. So the slope of a vertical line is undefined because the run is equal to 0. Alright, next. That is the answer to B. And now we can move on to C. All horizontal lines are perpendicular to the x-axis. And this is false because all horizontal lines are parallel to the x-axis. So if I were to draw a graph, that's a terrible line, oh my god. A graph with my arrows, of course, because they're necessary. And I'll just make a line, let's say that it's y equals 3. So that's the horizontal line. And the x-axis is just y equals 0. That's just what the x-axis is. And these two are parallel. And they're parallel, so C is false. All I can write down. Oh, that's not white. Okay. False. And I can just write down over here. All horizontal lines are parallel to the x-axis. I think I'll put this in caps lock to help you. Here. Oh, okay. I can put that in caps lock. Okay, nice. So now we can move on to D. Also, get rid of this graph. Okay, so D. It says all vertical lines are parallel to the y-axis, and that is true. Actually, I'll bring back the graph before, because I was actually helpful. Okay, this is true because if I were to draw a line, let's say this is x equals 3, then we can look at the y-axis as well, and these two are parallel. They're parallel because the y-axis is just x equals 0, and they have the same slope. So that's true. For E, For E, it says the equation of a horizontal line is y equals b, where b is the y-intercept. And I've said this before in the first question, and this is true, because it comes in the form y equals something, and that something just happens to be the y-intercept because y would always be that value. For F, it says the equation of a vertical line is x equals d, where d is the y-intercept. And this is false. And it's false because d in this equation would be the x-intercept, not the y-intercept. So we can just write down over here the equation of a vertical line is x equals d, where d is the x-intercept. Okay, that's there. Let's move that over here. Okay, and that is it. Actually, I think I'll explain this x equals d part. If I have my line that is x equals 3, you can see that it crosses the x-axis also at x equals 3. And when it crosses the x-axis, that is the x-intercept. So this whole line is what like the x-intercept is, and that's 3. So yeah, we can now move on to the next question. Okay, so question 8 says that a rectangle has all of the following properties, and these are: it has an area of 16 square units. The line y equals 2 lies on one side of the rectangle. The line x equals -1 lies on another side of the rectangle, and one side is 4 times the length of another. So let's just put some given information first. We know that this is a rectangle. Oh, that looks like a V. Okay. This is a rectangle. And rectangles, oh, well, this one, this one's area is equal to 16 square units. And the formula for the area of a rectangle is area equals length times width, or LW. And since it's 16, uh, we can just write down all of the factors for 16 to try to guess what length times width is. And these are 1 times 1 times 16. We have 2 times 8. We have we have 8 times 2, and we have 16 times 1. But if we look at this last property, it says one side is 4 times the length of another. And uh, 1 is not 4 times the length of 16, and 16 is not 4 times the length of 1. So we can just cross out 1 times 16 and 16 times 1, leaving only 2 and 8, and 8 and 2. And 8 is 4 times the length of 2. So this is right. So I think that we'll actually look at these two properties because uh, since since this is a rectangle, we can assume that these two lines intersect at one point, and that point would be -1, comma 2, because we have x equals -1 and y equals 2. So that's our point. And using this point, we can just branch off 2 and 8 on both sides, or -2 and -8 technically. So there are multiple ways that you could do this. I'll just do this one way. Um, but there's multiple of them, so I might not get the exact same answer as you. But that's okay. I'll just get something here. And I think what'll make things a little bit easier is to just draw a graph. And I think I'll make it really big. I'll use the line tool to make it more exact. Okay. And we have that. Okay. I'll just draw a 10. So this graph is obviously not perfect, but I think it'll help for now. And we're going to put our point, which is -1, 2, on this graph. And that would be -1 over here, and then comma 2. So this is our point. I'll put it in red. So that's our point. It's really important. And we're gonna branch off 2 and 8. So I think I'll just branch off by going 1, 2 over here. And I'll go and I'll go 8 on the x. So this is -1. So I'll do this is 1, 2, 3, 4, 5, 6, 7, 8, 8. And then we can also just go down to leaving us with this. And this point, I'll just label it as we did before. That is -1, 2. We know that for sure. That point, we just went up 2. So that is just -1, 4. This one we went across 8. So this will be 7, 4. And this one will be 7, 2. And these are our 4 coordinates. So I'll just connect uh, these 4 up to make our rectangle, and that's our answer. So this is our answer to quote question 8. These 4 points. So question 9, it says that lattice points are points whose coordinates are integers. How many lattice points are contained in the region bounded by the lines x equals -11, x equals 9, y equals 23, and y equals 18? So we can obviously see with these two vertical lines and 2 horizontal lines, this is obviously going to be a rectangle. So we're going to try to use the formula area equals length times width to figure out this answer. And so we can use the two x values, 9 and 11, and we're gonna find the we're gonna find the difference between them. So we have 9 minus -11, and that is equal to 20. But we're gonna have to take away an extra 1, leaving us with 19. Now I'll explain why we have to do this later. And we're gonna do the same thing for the y values, and that would get us 23 minus -18, which is gonna be plus 18, and that is equal to 41. Again, take away an extra 1, leaving us with 40. Okay, so this -1 was extremely confusing when I first learned it, but I'll try to explain it the best I can. And it's with this set of, let's say, 1, 2, and 3. So if we were trying to find the number of points in this set, then then we could take these two values and find the difference. So we have 3, and we can just minus 1, and that would leave us with 2. But there's obviously 3 points, not 2. So we have to add an extra 1, and that would leave us with 3. But I'm subtracting 1 here, not adding 1. So I'm subtracting 1 because, let's say this question, or let's say we have to find only the middle point here, or we have to exclude the points that are on the different that are on the edges of the set, like 1 and 3. Then we would subtract 1. So you have 2, and then subtract 1, and that would leave us with 1. So you have 1 point that is not on the edge. If I had another set that was, let's say, 1, 2, 3, 4, 5, and I wanted to find the number of points that are in the middle, I would take 1, the 5. Well, I would take 1 point, which is the 5, then minus 1, finding the difference. That would leave us with 4. And we're gonna have to take away an extra 1 to get us to the right answer, which is 3. Because there are 1, 2, 3 points that are not on the edges, or in the middle. So I'm just gonna delete this. So this question, it's asking us to find the number of lattice points that are contained in the region. So not on the actual lines of the point, or like not like we have to try to find the points that are inside of the region, and we have to exclude the ones that are touching the lines. But with that out of the way, we can now put these two values into our length times width formula, and we can just put area is equal to 19 times 40, and 19 times 40 is equal to 760. So therefore, there are, I'll just write this down, there are 760 lattice points inside the region. So yeah, that's it for today's videos. These are all of the problems for horizontal and vertical lines. Hope you learned something new. If you want me to improve on something in the future, you can drop a comment. I will look at them. With that, thank you. Goodbye.